In 1871, French sculptor Frédéric-Auguste Bartholdi arrived in New York and spotted Bedloes Island. He realized it was the perfect site for a massive monument to commemorate the anniversary of American independence. But the scale of his ambition created an immediate geographical nightmare. Bartholdi planned to design and manufacture a 46-meter-tall statue entirely in Paris, then ship the entire structure across the Atlantic Ocean to be permanently erected in New York Harbor. Traditional monuments of this era were cast in solid or thick hollow bronze. At 46 meters tall, a bronze casting would be so heavy it would collapse under its own weight, making it impossible to transport or even stand upright. To keep the giant structure light enough to survive, he opted for the copper repoussé method. This technique involves hammering highly malleable copper sheets until they are extremely thin, allowing for a huge volume with a fraction of the mass. To achieve this at scale, Bartholdi needed a modular system, a way to replicate the sculpture surface through hundreds of individual interlocking components that could be pressed against a precise mold. Success depended on calculation. Every component of the 46-meter structure had to be perfectly resolved in the workshop before the first crate ever left the Parisian docks. The massive undertaking started surprisingly small inside the Parisian workshops. The team built a base plaster model measuring just 2.11 meters tall, which served as a precise 1:16 scale master reference. To size this up, they relied on a strict mathematical scaling process. A series of divisions were traced directly onto the small plaster model, carefully mapping out individual, manageable segments of the statue's body. Each of these mapped segments was then blown up exactly 16 times to reach its final massive size. To hold that new volume in empty space, workers built a wooden-framed support structure for every single section. They heavily coated these large frames in plaster. This created full-size, positive templates of the statue's individual segments. Next, carpenters used those giant positive plaster templates as a base. They carefully built intricate, negative wooden molds around the outside of the plaster. With the negative wooden molds finished, the final skin process could begin. Laborers took 300 individual copper sheets, each only 1 to 3 millimeters thick, and physically hammered and pressed them into the wooden forms. This painstaking pipeline, from 1/16th scale model to full-size plaster to wooden mold to hammered copper, was the only way to guarantee that all 300 massive metal pieces would fit perfectly once assembled. Now they had a skin, but that introduced the next severe structural hurdle. They needed a way to keep 80 tons of thin copper standing upright against high winds without the metal buckling. The original architect, Eugene Viollet-le-Duc, planned to fill the statue's interior compartments with heavy sandbags to give it stability, but when he died in 1879, that plan was abandoned. The team brought in a structural engineer named Gustave Eiffel. He tossed out the sandbags and devised a highly innovative solution. He designed a light, flexible iron framework that the copper skin could hang from directly. To prove this internal skeleton worked, they conducted a trial run from 1881 to 1884. They attached the copper sheets to Eiffel's iron frame, assembling the statue right in the middle of a busy Parisian street. Crucially, they didn't weld or permanently affix the metal during this test. The team used simple, removable screws to temporarily attach the 300 copper plates to the iron struts. Once the trial proved successful, they completely dismantled the statue. The pieces were carefully distributed into over 200 wooden crates, which set sail for America on the ship L'Isère in May 1885. The temporary assembly in Paris proved the modular system was viable, shifting the focus from structural engineering to the logistics of a transatlantic move. When the crates arrived in New York Harbor in June 1885, the project hit an immediate wall. The Americans were responsible for funding and building the pedestal on Bedloes Island, but it was completely unfinished, halting all assembly. The delay stretched on until newspaper owner Joseph Pulitzer launched an aggressive press campaign. He shamed the public and wealthy elites into donating, finally generating the missing funds needed to complete the base designed by architect Richard Morris Hunt. By the spring of 1886, the enormous stone pedestal was ready, and the final permanent assembly of the 300 copper pieces could get underway. Instead of temporary screws, workers drove in specialized copper rivets to lock the thin plates to the iron supports. These flush rivets matched the exact copper of the skin, practically disappearing to give the monument the appearance of a single, seamless metal surface. After years of delays and intense physical labor, the permanent structure was finished. The official inauguration took place on October 28, 1886, celebrated with speeches and a massive naval parade surrounding the island. Liberty Enlightening the World is the result of precise mathematical scaling and modular engineering, a monument of 300 individual copper fragments, mapped, shipped, and reconstructed into a single seamless whole.